So today's the day we talk about scale, 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 and scale. Uh, if you're into Kubernetes, tomorrow is Kubernetes, 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 Kubernetes. Not by me, but other people. But yeah, fuck, I'm nervous. I'm here today to talk to you about deletion. How we took a manual process and something that involved many humans and automated the fuck out of it. Uh, pretty much all of it, honestly. I'll tell you how that reduced our on-call burden. That's something that all of you want to hear, I'm sure. And it also saved us a bunch of resources. I'm not actually allowed to use the word money, but I did. Crap. Uh, I'll also go over some of our fuck-ups. I'm supposed to say mistakes there. And I'll also share what we learned from them. Hey, I'm Anirudh, Annie. Uh, I'm a production engineer at Facebook, and I work on a team called Rackstorm. We're not actually anything about racks or about storms. I don't know how that name came about, but we got to stick with it now. Uh, Today I'll talk about hardware decommissioning at Facebook. We'll go over the need for it. We'll take a quick walk down memory lane and see how we proceeded to automate it. And finally, I'll share our vision for the future in this space. To start with, Facebook is huge. Massive is the word Corey used, I think. What began as a simple website run out of a dorm room is now a vast ecosystem spanning continents. I believe Sherry referred to some of that. As the company grows older, so does its hardware. You can't eliminate wear and tear, really. As new locations come online and new hardware becomes available, older locations have hardware that becomes obsolete or reaches the end of its shelf life and needs to be decommissioned. With a smaller hardware presence, this would be relatively easy. You just find the machines that are about to retire, identify the services that run on them, find replacements for those machines, ping the on-calls, and ask them to migrate. But Facebook has 14 geographic locations. When I submitted the abstract for this talk to SRECon, we had 12. By the time SRECon came around, it was 14. We also have tens of thousands of servers. That's quite a lot of servers with limited lifespans. And we can't afford to have our on-calls spend all of their shifts just dealing with service migrations, hardware decommissions, things like that. What's more, we buy servers in bulk. Surprise, surprise. So what that means here is a whole lot of machines expire at the same time. This is actually a pretty good time for me to tell you how we used to do migrations. And it was all, so I'll talk mainly about the planning phase, and a clue to how we did the planning is one word: spreadsheets. Yeah, it was spreadsheets all the way down, and we had to get rid of them because who likes spreadsheets? I mean, come on. Until recently, the decom events were small enough and few and far between enough that we just did them manually. In a decom, the most moving parts, the sub-process with the most moving parts is service migration. Moving your service from one set of machines to another so that you can decommission the first. The rest, we just treat them as constant factors. I mean, it's just unplugging and junking machines. Many different services reside on our machines, and all of them are managed by the teams that created them. Decommissioning a set of machines means that all of these different servers need to migrate. And going back to the clue word I used, there is no one place for us to keep track of, there was no one place for us to keep track of service migrations. For a given decom event, program managers just maintain spreadsheets with affected services listed on them and use those for everything ranging from identifying replacement machines to tracking the tasks that they filed against service on-calls, asking them to migrate. But of course, on-calls have other shit to do. Surprise again. And the program managers handling decoms ended up having to do things like pinging them on Messenger, writing groups posts, Basically, many forms of begging and pleading to move the fuck off of old hardware so that we can decom them. And here's the thing, data centers have limited space. Like, space does not scale as easily as software does. So we sometimes literally had servers just sitting in loading docks, waiting for space to be cleared up so that we can install new ones. The actual migration often was just a script that an on-call would run. Surprise, surprise. But sometimes it was a bunch of steps that was handed down the generations through a run book. And some very, very rare times, it was just tribal knowledge. Hey, Dave knows how to do migrations. Let's talk to Dave. But these steps were often very simple, and they followed a fairly common pattern. It was just setting up the replacement machines, letting the job scheduler know that these machines exist, and letting it start using them, whatever job scheduler that would be. And for retiring the machines that were about to be removed, stopping the flow of traffic to them, moving all sorts of moving state and data out of those, away from those machines, stopping the jobs running from them, and removing them from the job scheduler's awareness. This whole thing was not fast enough. We were so badly slowed down that every single decom event was held up by the last service to get out of the set of machines we were decomming. And all of this was just consuming power and space without providing anything in return. What's more, since humans did all of this, the process was fairly error prone. We had the whole shebang of outage reasons, ranging from incorrectly draining servers, unplugging servers without draining them. Sometimes even services started reusing servers that they had drained in the past because the decom was so slow that job schedulers just saw, hey, these machines are sitting idle, let's use them. They just forgot that they already drained them. The only lesson we learned from all of this is humans are human and will make mistakes. And we can't fix humans. Well, we can, but that's a bad thing. The whole process was only going to get slower as our data center footprint grows. Did I miss a slide? Oh yeah, crap. Right. So this whole thing had to be improved. We first built a UI because that's the first thing you do, right? But this UI kind of made sense at the time. It was just a UI to verify and kick off batches of migrations to make sure that the right set of machines were being decommed and the right set of machines were replacing them. At first, this UI only created task tickets to service on calls. In parallel, my team was also working on a framework that would run automated migration handler jobs, which would take a set of retiring machines, take a set of replacement machines, and look up what kind of migration handler to run for them, and spawn those jobs. Any sort of failure in the jobs would end up in the framework bailing out to the service on call through a task ticket. And we built a state machine over the internal ticketing system that would allow on-calls to do things like trigger retries of their automation, or just mark the ticket as complete and mark those machines as ready to decom if they did it manually. We realized that we could just plug this UI into our, we could just plug this framework, the state machine thing we built, into the UI because nobody had automation yet. And this was the same kind of error that would result in a task ticket to service on calls that a program manager was just clicking to create manually anyway. This helped us get services on board way faster than we expected. That's a good thing. Because once a service got a migration handler, the framework had nothing to do because program managers had nothing to do because the framework would no longer fail out to a task saying there is no migration handler, but it would just run a migration handler that it identified. It helped us iterate much faster than we expected. We were all very surprised. At the heart of it, we built the migration handler framework as a prototype to take in two sets, as I said earlier. One of machines that were being retired and one of machines that were ready to use. The end goal was also fairly simple. At the end, retiring machines were expected to no longer be in use, and the replacement machines were expected to be in use with the job schedulers running machine stuff on them. Uh, Services were free to write any sort of code in between because it was all just Python. And we as a team built a few migration handlers for common use cases, which service owners could just reuse as is, or which they could read up as patterns to write their own migration handlers. It was fairly useful code as documentation. And as I mentioned, we had our beautiful task state machine to rely on. We first attempt to run service migration automation. If there is no automation, or if the automation fails, we end up creating a ticket to the service on call, who tries to fix it or to unblock the migration, or ends up just doing it manually. Because that's also an option. Sometimes, like if you have like 3 machines to decom, you don't want to go through the whole process of fixing a migration handler and then unblocking the migration. And subsequently, the on-call just has the ability to tell the framework, hey, just move to the next stage. I'm done with these machines. Subsequently, we added a whole lot of other pieces to the puzzle too. We added a way for services to automate the placement of replacement capacity orders, because we need to buy those machines before installing them. We added a workflow system to tag and keep track of assets as they move through our flow. And we added a service that I call, the real name is really boring, so I call it the glue factory or the robot butcher, depending on my mood, because that service just utterly wipes them the fuck out. And that last service is how we fucked up the first time. You see, we started running this in prod. And like I said, we were all surprised how quickly we moved. But move fast is a thing at Facebook, I guess. So one of the first migration handlers that we released in prod was for a cache service. And that migration handler, surprisingly, had a defect that did not get triggered often, and it did not get caught in testing. Like, I expect tests to be perfectly accurate every single time. I don't know about you. But of course, this ended up in machines being sent to the glue factory while they were still in use. The glue factory didn't really check if machines were drained if they were not in use, because who sends machines there without draining them? And it just quietly unprovisioned them. And by unprovisioned, I mean wiped them the fuck out. Boom. Production was not noticeably impacted, thankfully. We just took down a small cluster. The site did not go down. Mark Zuckerberg was not pissed off. The site didn't even slow down. But we had taken live machines serving user traffic and slaughtered them. That was fun. That was a lot of fun. We ended up pushing migration handler writers to set all of their retiring machines to a new state that we added to the hardware management system. That state was simply called returned. So this way, we could ensure that machines had actually been looked at and touched by the migration handler, that is, before we called the migration as completed. We also made sure that job schedulers would not run any machines on, would not run any jobs on machines that were in the returned state. And we, of course, enforced in our framework that retiring assets have to be in this state at the end of a migration. Else we triggered a failure mode that would send tickets to the service on call. Speaking of tickets to the service on call, remember when I said humans don't read? No, wait, I didn't say that yet. Sorry. So humans don't read. That was our second sev, and we had not yet productionized the fixes from the cache killer sev, so we weren't really protected from this one either. Let me recap a little. We had changed the entire service migration process. The changes seemed, from a user's perspective, it seemed fairly inconsequential, but we had just pulled off the tablecloth from under a whole lot of fine china with dinner still on them, which was, yeah, sure, we did that. It was good, but in small cases it wasn't. So one fine day, a human got a task asking him to please migrate from one set of machines to another. And that guy, he probably had dealt with a whole lot of migrations in the old, this is the way we used to do things manner. So he did what he usually did and just triggered a long and slow drain process and marked the ticket as completed. Which, of course, in our framework means that the retiring assets will be sent to Robot Butcher. Uh, which, of course, as I said earlier, just kills machines because that's what it's designed to do. Insert Rick and Morty gif. Uh, the task also had a very clear, concise description that said something to the effect of, please make sure that your retiring assets have been drained and they are ready to decom before you mark this ticket as completed. What it should have also said was, it should have used fucking klaxon emoji saying, look, these machines are going to be nuked. You better not be using them when you mark this ticket as decommed. As completed. God damn, I lost all that effect. The ticket should have also said, once you mark this ticket as completed, we are going to nuke these machines and you will not get them back. So the lesson we learned here is we could have done a much better job of communication, both when we first launched our whole flow and also in each ticket that we sent to service on calls. Because when you involve humans in a process that's otherwise automated on both ends, you really want to make sure that they know what they're doing, and you want to make sure that they are aware of the consequences of their actions. Well, the whole thing went swimmingly otherwise, because I'm still standing here talking about the future. I still have a job, y'all. I can't really say y'all because I'm not Southern, but I'm trying to learn. We're in Nashville. But as I said earlier, service migrations followed a fairly uniform pattern. You just add replacement machines to some sort of job scheduler awareness, and you drain and remove the machines that are retiring. We realized that we could solve a few more problems by just decomposing this into separate handler types for adding and removing capacity. That would allow us to both run a service migration by composing add and remove capacity handlers together, and we could also run them individually and just remove capacity or just add capacity to a service. This allowed us to support a whole bunch of use cases from people who came to us looking to automate the turning up or the turning down of their services. These were people who wanted to do things like new hardware testing, like say I'm getting a new kind of CPU architecture, how will that look on my service? All the way down to disaster recovery, where hey, if I just remove a bunch of my capacity, what's my service going to do? We also supported a whole bunch of one-time migrations, stuff like going from bare metal to virtual machines. But for the most interesting use case we received was someone asking us to help them continuously rebalance our data centers. Basically, the idea was some parts of our data center end up consuming a whole lot of shared resources, such as power and network. And we want to distribute those hotspots around the data center so that the usage pattern is more uniform. And we are able to do that because we are able to just add capacity in one region, remove capacity in another region, which is pretty cool. We also realized that while waiting for a set of servers to fully get drained so that we could remove them, the machines that had already been drained were just sitting there idle, and we could run some stateless services on them to make more money, resources. But yeah, those stateless services, we made sure that they were whitelisted with the awareness that those machines can be taken away at any time without a drain. You just have to live with it because you're getting free capacity. And that worked. That really gave us a whole lot of resources. We were able to extract every last drop of compute juice out of our machines before decommissioning them. We also ended up doing, we've planned to do some stuff around hardware maintenance automation. Very often we've noticed that the service that runs hardware maintenance automation for us, they see maintenance is being blocked because, hey, my service doesn't have enough capacity for me to take down this rack of machines. So what we've decided to do is we've just decided to migrate those services to a spot in the data center which is not affected by the maintenance scope, and then the maintenance service can just take down those machines because they are no longer running anything. But yeah, we learned a whole lot from this whole shebang. So we've been running automated service migration in prod for over a year now. Shipping features early and often helped us gain a whole lot of feedback, made our rollout way easier. We didn't really have to do too much work once we had the task state machine in place. And now that we have most of our fleet automated for service migrations, we are seeing a drastically reduced human involvement. We are seeing fewer errors, and we are seeing a whole lot more consistency and speed in migrations and the overall hardware decom process. With uses beyond just hardware decom, such as data center rebalancing and disaster recovery and stuff, this has been a really good investment for us and will continue to be so in the future. Please don't fire me. Yeah, but I'm done. Questions?
So you were saying that one of the things that you did was reclaim capacity that had been marked as decommissioned, so you could use it for stateless stuff.
Yeah.
So there are multiple reasons why you would decommission a machine. Like one of them is it's old, it's slow, toss it in the bin. Another one is, hey, it has EEC errors or the disk is failing. Is there a way that you differentiate between those two states so you never put a machine that is degrading and possibly causing issues back into service?
That's a really good question. We haven't really seen anything like that happen, possibly because we just have so many machines. So with this service that picks up machines that have been tagged for decom and started and lets other services start using them, we basically guarantee nothing, no SLA, no SLO, none of those stuff. The machines you pick up could fail, the machines you pick up could have weird errors, they could be lemons, for all you know. It's basically we are providing it as free use, and services that sign up to use them are aware of this. And we've noticed typically that services that end up using these machines are things like these are basically services that just need computers, like things that run compute. Shit like video encoding. Like you want to see that Happy Friendship Day message. It doesn't matter if a few of the machines fail. The job's going to run somewhere else anyway.
Do you actually put those? So one of the ways you could mitigate that is not to put those machines in prod. You could just use them in dev or test or staging or whatever. Do you actually put some of these machines back in prod, or is it up to whatever team to decide what they want to put in?
We just put them back in prod. We don't really do too much with dev and test. But yeah, typically we just see that services, like if these machines fail, we end up just powering them off and no one can use them anyway.
Yep, thanks.
Thank you.
So once you decommission the old machines, you still need someone to physically swap out the old hardware and pop in the new hardware. Mm-hmm. How do you guys kind of manage that?
I actually don't know. There's some gremlin sitting somewhere doing that. No, but we have site teams who do that, and so I call this constant factors, and what I meant by that is that process has already been streamlined. We have people who just pull out entire server racks, and take them out to the back and shoot them, I guess. But yeah, like that process is something that we haven't been involved with too much, and because that just happens on site. I do everything from my desk. I have been to a data center exactly twice, and I've not really touched a server ever. So lucky me. Yeah.
All right, thank you.
Thank you.